Hi guys, welcome back to the discussion of Chapter 5, Population Genetics. But in this video, we are going to be discussing Part 2 of your module, when the population is no longer in equilibrium. These are the learning objectives that you need to complete by the end of the lesson. At the end of the lesson, students should be able to explain population genetics, gene pool, allele frequencies, and genetic equilibrium. Students should also be able to state Hardy-Weinberg law, explain the 5 assumptions of Hardy-Weinberg law for genetic equilibrium, and calculate allele and genotype frequencies. Let's take this question as an example. In a population of pea plant, 270 out of 3,000 plants were short. Shortness in pea plant is due to the recessive allele small t. Assume that this population is in equilibrium. Calculate the allele frequencies in this population. You are free to pause this video now to try on these questions. Now let's get back to question A. What the question really wants? The question wants us to find the frequency of dominant allele and frequency of recessive allele. Given in the question, we know that there are 270 homozygous recessive individuals. So therefore, the frequency of homozygous recessive individuals, Q square, is equal to 270 divided by 3000. From here, you can find the value of frequency of recessive allele, Q, simply by finding the square root of Q square, giving you the value of 0.3. Since P plus Q is equal to 1, so therefore the frequency of the dominant allele, P, is equal to 1 minus Q, 1 minus 0.3, giving you the final answer of 0.7. Now question B. Find the percentage of individuals who have dominant phenotype but carrying a recessive allele in the population. How do we solve this? First, we find the frequency of heterozygotes, 2pq, and then we convert it into percentage form. Since we already found the value of p and q, we can calculate the frequency of heterozygous individuals, 2pq, simply by multiplying 2 to 0.7 to 0.3, giving you the value of 0.42. From here, we can find the percentage of heterozygous individuals simply by multiplying the frequency of heterozygotes 2pq by 100, giving you the value of 42%. The next question says, if all the short pea plant were wiped out due to a lethal disease, calculate the new dominant and recessive allele frequencies. This situation indicates that natural selection has happened. So in this case, you can no longer use Hardy-Weinberg equations to calculate the various frequencies for the new population. Instead, you have to go back to basic of finding the frequencies or proportion. Remember that to find proportion, we simply divide part to the whole portion. To help you solve this kind of question, you need to construct a table of numbers. In this table, you will have various informations from the original population and the new population. For example, the number of homozygous dominant individual, the number of heterozygous individual, the number of homozygous recessive individual, and also the total individual in the population. From the question, we know that the original population is made up of 3,000 individuals, out of which 270 individuals were homozygous recessive individual. From all the information that we gain by solving the previous questions, we can calculate the number of heterozygous individuals and the number of homozygous dominant individuals in the original population. We know that there are 1,260 heterozygous individuals and 1,470 homozygous dominant individuals in the original population. Since all the short pea plant were wiped out due to a lethal disease, in the new population, the number of homozygous recessive individuals becomes 0. The number of homozygous dominant individuals and the number of heterozygous individuals remains the same. Since the new population are now lacking 270 individuals, the total number of individuals in the new population becomes 2,730. First, let's find the total number of allele in the new population. since every individual carried 2 copies of the allele. So therefore, to find the total number of allele in the new population, you simply multiply the new total individuals by 2, giving you the value of 5,460 alleles. Now let's find the total number of dominant allele in the new population. 2 dominant alleles can be found in each homozygous dominant individual. Meanwhile, 1 dominant allele can be found in each heterozygous individual. So therefore, to find the total number of dominant allele in the new population, you add number of homozygous dominant individual times 2 to the number of heterozygous individual. In this case, 1,470 times 2 plus 1,260, giving you the value of 4,200 alleles. From here, we can find the new dominant allele frequency P for the new population. We simply divide the total number of dominant allele in the new population by the total number of allele in the new population. In this case, 4,200 divided by 5,460, giving you the value of 0.7692. Please remember that this is the situation where the population is no longer in equilibrium. So remember not to use P plus Q is equal to 1 to find the frequency of the recessive allele for the new population. You simply have to do the basic way by dividing part to the whole portion. To find the frequency of the recessive allele Q in the new population, we first have to find the total number of recessive allele in the new population. 1 recessive allele can be found in each heterozygous individual. However, 2 recessive alleles can be found in each of the homozygous recessive individual. Since there is no more homozygous recessive individual in the new population, so therefore the total number of recessive allele in the new population is only 1,260 alleles. From here, we can find the new recessive allele frequency Q for the new population. We simply divide the total number of recessive allele in the new population by the total number of allele in the new population. In this case, 1,260 divided by 5,460, giving the value of 0.2308. Now let's take a look at another example. Albinism is the recessive condition whereby an individual is partially or completely absent of pigment in the skin, hair, and eyes. It affects 1 in 20,000 individuals worldwide. In an island of 100,000 individuals, and consider that all the Hardy-Weinberg conditions were met. A. Calculate the various genotypic frequencies for this gene. You are free to pause this video if you would like to try these questions. Now back to question A. What does the question want? Various genotypic frequencies means that the question wants us to find the frequency of homozygous dominant individuals, p square, frequency of heterozygotes, 2pq, and frequency of homozygous recessive individuals, q square. Given in the question that the frequency of homozygous recessive individuals, q square, is equal 1 over 20,000, giving us the value of 0.00005. From here, we can find the frequency of recessive allele q by finding the square root of q square, giving us the value of 0.0071. Since p plus q is equal to 1, so therefore the frequency of the dominant allele p is equal to 1 minus q, 1 minus 0.0071, giving us the final answer of 0.9929. From here, we can find the frequency of homozygous dominant individuals, p square, simply by squaring 0.9929, giving us the value of 0.98585. Since p square plus 2pq plus q square is equal to 1, 2pq, or the frequency of heterozygous individuals, is equal to 1 minus p square minus q square, giving us the final answer of 0.0141. Question B. Calculate the number of individuals who would be albino in this population. To find the number of albino individuals in the island population, We simply multiply the frequency of homozygous recessive individual Q square to the total number of individual in the island population. In this case, 0.00005 times 100,000, giving us the value of 5 individuals. Question C. Calculate the number of normal individuals who are carrier for albinism in this population. What does the question want? The question wants us to find the number of heterozygotes. To find the number of heterozygous individuals in the island population, we simply multiply the frequency of heterozygous individual to PQ to the total number of individuals in the population. In this case, 0.0141 times 100,000, giving us the value of 1,410 individuals. Question D. If 1,000 normal individuals, of which 600 were carrier, migrated into the island, calculate the new allele frequencies of this population. You are again free to pause this video to answer this question. First, construct the table of numbers. From the question, we know that there are 100,000 individuals on the island, 5 of which are homozygous recessive individuals. We also know that 1,410 were heterozygotes. This means that 98,585 individuals were homozygous dominant individuals. Because of immigration affecting the number of normal individuals, the number of heterozygous individuals and the number of homozygous dominant individuals in the new population has changed as follows. The number of homozygous recessive individuals remains unchanged. Since 1,000 individuals has migrated into the island, the total number of individuals on the island has increased to 101,000 individuals. To calculate the new allele frequencies in the population, we first find the total number of allele in the new population. We simply multiply the new total individual by 2, since each individual will carry 2 copies of the allele, giving us the value of 202,000 alleles. To find the total number of dominant allele in the population, we look into homozygous dominant and heterozygous individuals. Since each homozygous dominant individual carries 2 dominant alleles, hence we time the value to 2. In this case, 98,985 times 2 plus 2,010, giving us the value of 199,980 alleles. From here, we can find the new dominant allele frequency P for the new population. We simply divide the total number of dominant allele in the new population by the total number of allele in the new population. In this case, 199,980 divided by 202,000, giving the final answer of 0.99. Again, since this is the case where the population is no longer in equilibrium, please remember not to use P plus Q equal to 1 to find the frequency of recessive allele, Q. To find the frequency of recessive allele in the new population, we first find the total number of recessive allele in the new population. Recessive allele can be found in heterozygous individual and also homozygous recessive individual. Each heterozygous individual will only carry 1 recessive allele. Meanwhile, homozygous recessive individual will carry 2 copies of the recessive allele. So therefore, you have to multiply the value with 2. In this case, 2010 plus 5 times 2, giving you the value of 2020 alleles. From here, you can find the new recessive allele frequency Q for the new population. You can do this simply by dividing the total number of recessive allele in the new population to the total number of allele in the new population. In this case, 2020 divided by 202,000, giving you the value of 0.01. Now let's take a look at the last example. Widow's peak is a dominant trait compared to straight hairline, whereby a widow's peak individuals have a V-pattern hairline towards the center of the forehead. In a population of 120,000 individuals, 100,000 having widow's peak hairline. Assuming that this population is in equilibrium. A. State the Hardy-Weinberg principle. The Hardy-Weinberg principle states that in a population in equilibrium, The allele and genotypic frequencies remain constant across the generations. Question B. State 2 Hardy-Weinberg conditions. There are 5 Hardy-Weinberg conditions to choose from. These include no mutation, no migration, no natural selection, large population size, and random mating. Question C. State 2 Hardy-Weinberg equations. These are P plus Q is equal to 1 and P square plus 2PQ plus Q square is equal to 1. Question D. Calculate P and Q of this gene in this population. From the question, we know that only 20,000 individuals are homozygous recessive. So therefore, to find the frequency of homozygous recessive individuals, Q square, is equal to 20,000 divided by 120,000. From here, we can find the frequency of recessive allele Q by finding the square root of Q square, giving us the value of 0.4082. Since P plus Q is equal to 1, so therefore the frequency of the dominant allele P is equal to 1 minus Q, 1 minus 0.4082, giving us the value of 0.5918. Question E. Calculate the number of purebred dominant individuals in this population. To do this, first find the frequency of homozygous dominant individuals, P square, simply by square rooting 0.5918, giving us the value of 0.3502. To find the number of homozygous dominant individuals, we simply multiply the frequency of homozygous dominant individuals, P squared, to the total population. In this case, 0.3502 times 120,000, giving us the value of 42,024 individuals. Question F. Calculate the number of heterozygotes in this population. To do this, we first find the frequency of heterozygous individuals, 2PQ, in the population. The final value is 0.4831. To find the number of heterozygotes in the population, we simply multiply the frequency of heterozygous individuals, 2PQ, to the total population. In this case, 0.4831 times 120,000, giving us the value of 57,972 individuals. Question G. If all the individuals with straight hairline emigrated out, calculate the new allele frequencies for this gene. Due to large numbers and many decimal places, the numbers that we have calculated before does not quite fit. To make this question slightly easier for you to answer, I have adjusted the number of homozygous dominant individual, heterozygous individual, and homozygous recessive individual. You can use these values to calculate the new allele frequencies for the new population. You are free to pause this video to try this question. Question G states that all the individuals with straight hairline, i.e. homozygous recessive individuals, emigrated out. So therefore, in the new population, there will be 0 homozygous recessive individual. The number of homozygous dominant individual and heterozygous individual remains the same. Since 20,000 homozygous recessive individual has emigrated out, the new population now consists of 20,000 individuals less. To find the new allele frequencies, we first begin by finding the total allele in the new population, simply by multiplying the new total individual by 2, simply because each individual will carry 2 copies of the allele, giving us the value of 200,000 alleles in total. To find the total number of dominant allele in the population, we look into homozygous dominant individual and heterozygous individuals. Since homozygous dominant individual carries 2 copies of dominant alleles, hence the value needs to be multiplied by 2. In this case, 42,020 times 2 plus 57,980, giving us the value of 142,020 alleles. From here, we can find the new dominant allele frequency, P, for the new population, simply by dividing the total number of dominant allele in the new population by the total number of allele in the new population, in this case 142,020 divided by 200,000, giving us the final value of 0.7101. Since this is the situation where the population is no longer in equilibrium, remember to never use P plus Q is equal to 1 to find the frequency of the recessive allele, Q. To find the frequency of recessive allele, Q, we first find the total number of recessive allele in the new population. To do this, we look into heterozygous individual and homozygous recessive individual. Each heterozygous individual will carry only one recessive allele. However, each homozygous recessive individual carries 2 copies of the recessive allele. Since there are no more homozygous recessive individuals left in the new population, so therefore the total number of recessive allele in the new population is the same as the number of heterozygous individuals, which is 57,980 alleles. From here, we can find the new recessive allele frequency Q for the new population. To do this, we simply divide the total number of recessive allele in the new population by the total number of allele in the new population. In this case, 57,980 divided by 200,000, giving us the value of 0.2899.